Hello everyone, my name is Lucas. Today I will give you a brief introduction of Huawei Cloud IoTDA. So D means device, A means access. So basically, you can see here, this is the IoTDA overview. As you can see here, in the middle you can see this is Huawei Cloud IoTDA. And on the left side we can see that's devices, and on the right side we can see here is the industry applications, and this is other services on Huawei Cloud. So so let's go to the left side. You can see here the devices. So basically, all kinds of devices are allowed to connect to the IoTDA if the device have the basic capabilities of network and protocol. And you can see here, so this is the devices, and for the device reporting, so that means the device can report data to the IoTDA, and the IoTDA will handle the link of with the devices and handle with the data the device report, and then IoTDA can transfer the data to users' applications, maybe a mobile phone app, maybe a website, things like that, and also can forward the data to other services on Huawei Cloud, like OBS, like MySQL, like big data, like AI, things like that. So basically, IoTDA can receive the data from the device and transfer the data to users' applications and other services on Huawei Cloud. and for the command delivery, you can see here. So the industry applications can also send the command to control the devices, things like that. So the application send the command to IoTDA. The IoTDA will handle the data, handle the command from the applications, and then send the command to devices. So basically, you can see here. So this is like two basic workflow of IoT scenario. You can see here, device report the data to the IoT platform, and then IoT platform transfers the data to your applications, and then for the command delivery, applications send the command to IoTDA, and the IoTDA sends the command to devices. So basically, that's the two typical data flow in IoT industry: data reporting and command delivery. So let's go to the details of IoTDA. As you can see here, we have like 6 features of IoTDA: device access, device management, communications, rule engine, device provisioning, and the intelligence on them. Let's go to the details one by one. So for the device access, we have like native. We support like native protocols like MQTT, which is most popular, most common protocol in IoT industry, and the LWM2M and the COAP, COAP, and the HTTP2, HTTPS, HTTP, things like that. So that's native protocols. So if your devices already have this kind of native protocol, and then you can just set up some parameters so that you can connect your device to the cloud IoTDA. You can see here, and the industry protocols, maybe for some maybe for some certain industry, maybe water meter industry, maybe some gas meter industry, things like that. So that means that industry have their own like protocol. So that means we already support the industry protocols. In China we can like the water meter protocol. We also and maybe JT, it's like JT 808. It's like in China, it's like it's like a common protocol in transportation industry, things like that. So we also support custom protocol plugins. So that's the reason why I said that IoTDA can support all kinds of devices if the device have the basic capabilities of network and the protocol. So that means if your devices have your own private protocol, you can also connect to the IoTDA. Yeah, because IoTDA support the protocol like you based on TCP. Yeah, for example, TCP, right? And then you have your own private protocol based on TCP. You can also connect to the IoTDA. We have like plugins. We already have demo. We have like a software, like a demo software. It's like based on maybe the software is open source, so that means all customers can download the open source software and deploy your software within like IoTDA. Yeah, just using two kinds of, just achieving two kinds of functions. The first one is like decode, another one is like encode. Yeah, because you know Huawei Cloud IoTDA is a platform, so that means we cannot support all kinds of like private protocol. Yeah, because it's not standard, right? So maybe different customer have different private protocols. So we just give like a plugin demo. Yeah, you can download the plugin demo, just achieving the two functions. Yeah, it's like decoding and encoding. Yeah, and then you can just connect to the IoTDA directly, even you are using a private protocol. Yeah. And we also support the edge cloud collaboration. Yeah, it's like you can think that if the devices if the network of the device is not so stable, right? So, but your device need to handle the data from the device like with low latency. So that means, yeah, so that means maybe we will like to have IoT edge, yeah, to be with maybe close to the devices. So that means it can handle the data with maybe a better network, things like that. Yeah, and when the network to the public network becomes stable, yeah, so the IoT edge can send the data to IoTDA automatically. Yeah, so basically IoT edge had the part of the features of the IoTDA. Yeah. So that's edge and cloud collaboration. So so for the device management, it's like common features like lifecycle management, like you can manage the whole life of your devices, like the create a device, like modify a device, like delete a device, yeah, things like that. So so this is like the basic features. And the device modeling. So this part is quite important in IoTDA. The reason why I said that it's kind of like a file. Device modeling is kind of like a file, and that file describe what kind of devices it and what kind of data your device want to report, and what kind of command your device want to receive. Yes, things like that. So device modeling is kind of file. It's like maybe it's like a digital twin. Yeah. Of your devices just deployed in IoTDA. So this is quite important. And for the OTA upgrade, so it's like a common feature. Yeah, you can just load it for you to upgrade maybe your software in your device. And you need to be with the device. It's like to be with device maybe and do the upgradation. So that's loaded. You just can do the upgradation maybe in a remote way, maybe just some clicks in IoTDA, maybe just send some command to IoTDA, and then IoTDA can do the upgradation of your devices automatically. Yeah, so that's the OTA upgrade. So device shadow. Device shadow is kind of like concept in IoT industry. So device shadows, they have like two zones. The first one is like desired zone. The other one is like a reported zone. So for the report zone, it's like device shadow always like store the latest data of the devices. So that means the latest data of the devices. So that means shadow, right? And for the desired zone, it's like what you want your device, what kind of data, and what the value of the data you want your device report. So that means the desired zone. So there's like two kind of zones within device shadow. And for the communications, it's kind of like the simple device data reporting. So just the device report data, data reporting and command delivery. Just the application send the command to IoTDA, and the IoTDA will send the command to devices, things like that. So command delivery, file upload. It kind of a feature that you can upload your file within IoTDA, and then your devices can download the file whenever the device want. Things like that. And the subscription and push. So basically, this is a very important features in IoTDA because for the applications you want all the data from the devices, right? Maybe you want to know the status of your devices. Maybe you want the message and your device report, things like that. So that means the subscription and push. So you can call the API or can just set up the configuration within IoTDA. So that means you can. So that means the application can get all the data from the devices. As you can see here, for example, if you already have your application and you want to know the device status. So that means if the status of your device change, so you want the IoTDA to tell you the data, things like that. So you just need to subscribe the device status notification. It's kind of like an event, right? You just need to subscribe the event, like the device status notification. And then if the device's status change, and then IoTDA will push the data to your application automatically. So it's like you subscribe the device status notification, and then if the status of your device change, and then IoTDA can push the data to your applications automatically, so that you can know. You can maybe do some monitoring. We'll send some people to check the reason why the device maybe from online to offline, things like that. So that's subscription and push. So basically, your application can get all the data of your devices. You just need to tell the IoTDA. You just need to subscribe what kind of data you want, and then IoTDA will get the data automatically to you. Will push the data automatically to you. Things like that. So the reason why all the IoT platform are doing this, because for the users, it's kind of like simple. You just tell the platform what kind of data you want, and if the maybe we have a lot of event, and if the event triggered, and then we will like to send the data to your application automatically. So you just need to tell the platform what kind of data you want, and the data will be pushed to your applications automatically. So that's subscription and push. For the RUA engine, you can see here that data forwarding. What I just said is like this. So the IoTDA can forward data to other services on Huawei Cloud, maybe MySQL database, maybe InfluxDB, maybe AI, maybe big data, things like that. And multiple protocol and multiple channel is like maybe you are using different protocol to connect to the IoTDA, and also the data can be pushed to other services on Huawei Cloud, maybe your own applications, maybe your HTTP, HTTPS, URL, things like that. So that means multiple channel, multiple protocols. So that means maybe different protocols connect to the IoTDA, and this data can be pushed to different destinations at the same time. Device linkage is like one device can control another device. Later I will show you the feature. It's like a machine to machine. For example, if there's like two different devices, device A, device B, things like that. So device A send the data to the IoT platform, IoTDA, and if you already maybe set up rules, within the IoTDA, and if the device A data trigger the event, and then it can control device B. Yes, it's like that. Device linkage. Yeah. So for the SQL processing, that means if you are reporting the data to IoTDA, and you can use the SQL processing to filter your data. Yes, it's like that. For example, we have a customer and their devices are vehicles. Yeah. So the vehicles are reporting two kinds of data. The first one is like location, and the other one is like speed. So if you only want the speed data can be stored within maybe MySQL, so that means we should filter the location data, right? So yeah, so that means you can use this SQL processing just filter one kind of data, yeah, and it will work. So that means your device, no need for your device to do the change, just using the raw engine to filter the data. Yeah, and for the device provisioning, it's like services that you can how to say, you can deliver your device automatically. Even your device change the URL. How to say? For example, if your device now in Singapore, so that means you should connect the IoTDA in Singapore region, right? So that means IoTDA have a Singapore URL. So that means your device can connect to the Singapore IoTDA. But if you change, if your device was sent to Bangkok, yeah, and then your device need to the same device, yeah, need to change the URL, yeah, because you want to load the you want to connect to the IoTDA in Bangkok, right? So that means you should do the upgradation of your software and to change the URL of IoTDA. But if you are using this kind of feature like device provisioning, that means no need for your device to do the change. You just you can just maybe change the URL automatically. So no need for your device to do the change if you are using the feature, because it will change the URL automatically. So that's the feature's most important function. Yeah. For the intelligence O&M, you can see here log analysis. That means we can save the log, because maybe sometimes you are using, because maybe sometimes there is something wrong with your devices, maybe in 2 a.m. So you cannot wait at that late, right? So that means you just need to some basic configuration within IoTDA, and then your log will be stored on the cloud automatically. So that means when you are at work, maybe 9 a.m., so that you can analyze the log. Yeah. Message tracing is like you can trace all the messages, the whole cycle, the whole life of the device, from the device to the applications. So that means you unload all the message tracing. Yeah. And the metric monitoring, yeah, you can do some monitoring. Yeah, it's basic features and exception detection. Yeah, we will detect the weird behavior of devices, like if your device are not using a security way to connect to the IoTDA, maybe you are using the MQTT, not MQTTs. Yeah, we will detect that. And maybe your device like log in, log out, yeah, within 1 minute. Yeah, so that means it's kind of like a weird behavior, right? So that means we will detect the weird behavior of the devices. Yes, it's like that. Also have some service alarms. Yes, it's like that. If your device maybe report alarm, things like that. Yeah, this is basically we have two different ways for the device to connect to the cloud. The first one is direct connection. So that means if your device have some native protocols like MQTT, COPE, HTTPS, LWM2M, WebSocket, and then that means you can connect to the IoTDA automatically, right? Because maybe you are using Wi-Fi, maybe 2G, 3G, 4G, things like that. So because So under this scenario, that means your device maybe have a lot of resources, so that you can integrate the IoT SDK, yeah, and you will have the native protocols to connect to the IoTDA. Yeah, that's the direct connection. And another scenario is that connection using gateway. Yeah, as you can see here, because these devices not have so much resources, they only have the near field protocols like ZigBee, LoRa, Bluetooth, Modbus, things like that. So that means they cannot connect to the public IP, right? They cannot access a public IP, right? So that means they need a gateway. So that a gateway can maybe connect to the cloud, yeah, maybe using MQTT, and then the gateway can connect the devices. So that means there's like a connection using gateway. Yeah. But by the way, for the at this scenario, we call this devices, and we call this is like sub devices. This is father device. This is son device. This is like that. Yeah, this is like that. So this is devices. That's the sub devices. But for the IoTDA, we can arrange the device, the sub device, things like that. And this is the SDK. So by the way, you can see here the traditional development model. So model is like in charge of connecting the network, right? And the chip is that you can deploy your own logic, maybe using SA and deploy within chip, maybe, and then how to and what kind of data you want to report, what kind of command you want to receive, things like that. So that means this will cost a lot of times, right? As you can see here. So you can see here, it's like it will cost a lot of times. But if you are using the pre-integration, like SDK pre-integration, like model, as you can see here, IoTDA already integrated within the model. So that means you only need 2 AT commands to connect to the Huawei Cloud IoTDA. Because the IoT SDK already there, right? So you just need to using the chip and to just maybe 2 AT commands and can connect to the IoTDA. So you can see it will shorten the time, yeah, saving a lot of time, yeah, right. And we just mentioned the model, yeah, already pre-integrated the SDK. So if you want to don't want to buy some pre-integrated SDK like model, so that means you can also deploy the device SDK by yourself. You can see here. So basically, we have a lot of programming languages SDKs like C, Java, Android, C#, Go, Python, yes, things like that. So basically, all the API from the IoTDA, yeah, the SDK already achieved. So you can see here there's a lot of features like device security, OTA upgrade, device intelligence, device provisioning, yes, things like that. And based on a lot of OS, you can see OpenHarmony, yeah, LightOS, FreeRTOS, Windows, Android, Linux, yes, things like that. So if you are using the SDK, so it will save a lot of time. Yeah, so basically why most of our customers like to using IoTDA because no need for you to understand the protocol, maybe no need for you to guarantee the performance of your software within the devices. You just deploy the SDK, you just call the API, yeah, and you can connect to the IoTDA. So it will save a lot of time. And this is device modeling, what I mentioned before. It's like a very important part within IoTDA. We also call it a profile of the device, right? As you can see here. You can see here, mine 1 from fender A, mine 2 from fender B, mine 3 for fender C, as you can see here. So they are using different protocol like Modbus, like TCP, like MQTT, and you can see here they are like their data format are different. You can see here voltage 1A, right? Voltage 32V. 32. You can see the data format are also different, right? So if for the system, if you want to adjust these 3 different mines, so that means you should adjust 3 different API, right? So if you have another mine from another vendor, so you need to adjust the API 4, right? So it's kind of like complicated. But if you are using the standard profile here, so for the system, just using the standard APIs. So if you have for like a Mine4, Funda-D, things like that, so no need for the system to do some change, So that means how important is the standards profile. You just need to design this. So basically, if you design the standard profile at first, and then no need for your backend to do the change. You just divide to adjust the data format of the standard profiles. So it will save a lot of times. This is for the, you can see here, it's for the OTA upgradation. Yeah, it's not so it's not so difficult. You can see here FOTA, SOTA, different kind of upgradation. Because no need for you to be with the devices and do some upgradation if your devices have some bugs, things like that. So just using a simple way, just maybe call the API of the IoTDA, or maybe just maybe click some buttons within IoTDA, and you can do the upgradation. It's quite, it will save a lot of time. This role and domain-based device management. So you can see this is not so complicated. It's kind of like basic features of IoTDA. Maybe different roles will have different permissions. You can see here. So maybe some people can only viewing and deleting a device. Some people can only creating a device. Some people can only like modifying a device, things like that. So different roles have different permissions. This is like the it's kind of like a plug-in, as you can see here. So if your device is maybe it's NB-IoT, it's an NB-IoT device, so that means the device don't have too much resources. So you can see here they only can receive or can send the data format of binary. But for the maybe for the applications, for your software, you want to receive data, it's like JSON, right? So how to change the data format, because your device only recognizes the binary, but your software are using JSON. So we need so that means we have middleware. We call codecs here. So codecs is like for data reporting, binary will be changed, will be transferred into like JSON. And then this is data reporting, binary changes, transfer the binary to JSON, and for the command delivery, like JSON, and will be the binary, will be transferred into binary, things like that. So we can have multiple models to achieve the codecs, maybe online JavaScript, script, you can use this JavaScript, and also zero code, just drag and drop operations on the GUI, And also this is serverless services on Huawei Cloud. It's like FunctionGraph. You can use this to achieve the codecs. Basically, this is for the generic protocols. So if you are using different kind of protocols based on TCP, maybe you have your own private protocol. You can use this feature. Just use the. So we have like architecture, we have like an open source demo. You just use it and deploy, within IoTDA, and your device can connect to the IoTDA directly. Even your device are using a private protocol. These are two like different ways of IoT scenario. The first one is like to IoTDA for the device, report the data, maybe using the MQTT topic, report the data to IoTDA, and IoTDA push the data to your applications. You can see here, data reporting to IoTDA and to your applications. For the command delivery, it's like application send a command to IoTDA, and IoTDA push the data to devices, things like that. That's the first scenario. Another scenario is M2M. It's like machine to machine. This is device to application, and this is machine to machine. You can device report data to IoTDA, and we set up a rule like message routing, and then the data can be sent to another device. So it's like that, right? this is device to application, this device to another device. Yeah, this like that. And as you can see, this is quite important features within IoTDA for the like the data forwarding, as you know here. So basically, we have like a lot of, as you can see, we have like a lot of like forwarding rules, as you know, forwarding rules, and we can have a lot of destinations, as you can see here. So as you can see here, so maybe we have a lot of data device resources like device change, device name change, the device status change, like device messages, things like that. So so we have a lot of device resources, and then you can see the other step is like forwarding target. So that means you can send your device maybe to, you can see here, maybe HTTP, HTTPS, maybe Kafka, maybe MQTT, maybe functions, another for the data storage, maybe OBS, maybe MySQL, yeah, maybe IoT analysis, maybe InfluxDB, yeah, as you can see here. So it's kind of like simple. So that means for the one data resources can be forwarded to multiple destinations at the same time. Yeah, and you just need to set up within the console. You know, this is the console of IoTDA. You just set up this, and you can also do some SQL filtering. Yeah, you can see to filter your data, and you can also step 2. You can just set forwarding target, maybe just a simple configuration, and just enable the rules. It will work all the time. So just maybe some parameters, and you will have your own rules. So this is kind of like device linkage, as you can see here. So this is kind of like typical one for the fire alarm to camera tracking to SMS pushing, emergency guidance, access control linkage, broadcast notification. Yeah, right. So one trigger one, one trigger one, one trigger one. So you just need to set up the rules within the IoTDA, and if the rules were triggered, and we will do the action you already set. Yeah. Device proficiency. What I mentioned before, as you can see here, if you have different like customers and the devices are in different region, maybe Beijing, maybe Shanghai, maybe Singapore, things like that. Yeah, but if you want to change maybe from Beijing to Shanghai, so that means you need to upgrade the software of your device, right? But if you are using the device provisioning features, so no need for you to change. You can see here. Just use you can see here device just use this kind of feature, and it will maybe it will like to be delivered automatically, maybe from Shanghai to Beijing, maybe from Singapore to Beijing. No need for you to change the code of your devices. You just need to set up some maybe some parameters, maybe some rules just within IoTDA, yeah, and it will be provisioned automatically. Yeah, so this is like a basic feature, device exception detection. So that means we will detect, you can see here, the device exception notification, and you can see here maybe offline course analysis. Yeah, so this is like detection. Maybe you are not using the security way to connect to the IoTDA. Yeah, we will detect that. So today is my presentation. Yeah, as you can see here. Also, if you have like Huawei Cloud account, yeah, as you can see here, you can also log in. You can also log in the Huawei Cloud account. If you already have Huawei Cloud account, that means you can, you can log in the Huawei Cloud, the IoTDA. Yeah, as you can see, I will show you. This is the main page of Huawei Cloud, yeah, and then you can click here, product. As you can see here, you can create product, and you can use like Internet of Things, right? Yeah, IoTDA. IoTDA. Yeah, click. Yeah, and you try free. Yeah, you will go to the console of IoTDA. Just try free, and you will go to the console of IoTDA. And if you want to experience it, then we will have like a document. Yeah, you just need to use a document, maybe get started. Yeah, we will have very quick way. Yeah, to monitor a device, maybe simulator device to connect to the IoTDA. We have simulators. Yeah, you can see here. Yeah, like a quick device access, quick application access. It's very simple for you to experience. So you can just use it. Yeah, thanks for your time listening my presentation. Thank you.